All right. Hello once again. This is AI Talks. And here is your mana potion made of highly concentrated machine learning energy. Exciting stories on the magic of AI and machine learning tools and know-hows from SoftServe. My name's Daniel, and I'm your host. And tonight, we will be talking about the essence of making a viable and effective AI-based project, our team. It comprises a whole spectrum of backgrounds from scientists, analysts, engineers, architects. Here at SoftServe, the dedicated data science team has been operational for over 8 years, and the collective experience of thousands of hours that were put to power up our clients' best AI practices is truly invaluable. Through trials and errors, we crystallize an approach to building the most effective ML squad. And to share the main insights about that, let me invite our speakers, Natalia, Polyakovska, and Dmytro Zikrach, for our today's talk. Welcome, guys, and to go ahead and take over my sharing.
Hi, everyone. One moment, I'll share my screen.
Okay, thanks, Daniel, for introduction, and thank you for everyone for joining. And I'm Natalia. I'm a data scientist at SoftServe, and today, together with our competence manager, Dmytro, we would like to present you how we build artificial intelligence products at our data science group at SoftServe.
Hi, everyone, and Natasha, let's start.
Okay. AI entered our lives and turns a view about many of industries, such as manufacturing, healthcare, finances, even space exploration, and many more. AI seems to be everywhere, and nowadays we are facing AI on a daily basis, and businesses are using it to operate more efficiently, with a result safer products with more accurate decision. But what is our AI product, and what do we need to build it? So to build and teach our artificial intelligence or machine learning model, we need to transfer some knowledge to it. And what is this knowledge in such case? Data. Depending on a business case, data amount, data structure, data type will differ, of course. But one thing is constant. Data is a power which contains a lot of information which can help our model to learn using different artificial intelligence and machine learning techniques, complex dependencies, and data insights and statistics. And what about computation? You must do a lot of it to build a high quality model. The more data you have, the better in terms of knowledge and accuracy of your decision. But you also must store and process sometimes enormous amount of data efficiently, flexible, and secure. And cloud services can help you with all of the above, besides, of course, all other benefits which cloud services provide us. And what we are doing it for, and what we would like to see as our outcome. And as outcome, we are building a data-driven solution, mostly of cloud in most cases. And what we would like to get? We would like to get perception, reasoning, and accurate decision-making to build a useful product and solution. So you probably have heard about AI and probably heard about our data science group, about our projects and clients, but have you heard about our challenges? So if no, let's discuss some of them. So the first main group of challenges are related to data, and data quality and data pipelines automation are critical things we would like to build useful artificial intelligence or machine learning models and solutions. And poor quality data leads to poor decision, because a decision cannot be better than the information upon which it's based. And critical decision based on pure data can have very serious consequences. So the easiest example here might be some data duplicates. And for instance, if you are predicting demand, and if you have duplicates in your data, your predicted demand will be many times higher than the actual one, which may lead to spoilage of products and consequently huge expenses. Of course, it's not an only issue with data, but it's just an example. And ensuring the quality in general and building the pipelines are not easy steps. However, there are many technologies that can help us with this, and we will not dwell on details about data issues and data quality today. So what about process? And usually we have many teams involved in our artificial intelligence project besides data science team. It might be data engineering team, just front-end, back-end, or full-stack engineers, and of course QAs and QC. And sometimes these teams used to work with different approaches and different velocities. And we have to find some trade-off on our work on these projects. And also we have new interdependencies between the team, which we should manage to handle and introduce these dependencies to other teams who have no experience with working on AI project. So it's different. It's difficult to doing testing on machine learning solutions as well, because the results might be not stable. And also the problem in processes that software development lifecycle, which most of the developers use to, doesn't match model development lifecycle almost all the times. And what about skills? So AI covers very huge number of various technologies, algorithms, domains, and skills. And of course, one person cannot handle all of this. So it's important to dedicate the right person to his right role and skills for some particular project or some part of this project. And lack of the industry standard might lead this to a real challenge. We had cases when one person was responsible for a whole project from data science perspective, and it was successful even for a huge project. But we understand that it might be done more optimal, assigning different people to different parts of project to make it faster and easier, and to use strongest sides of any teammate. And later in this talk, Dmytro will present you how we deal with it in SoftServe and present our roles and responsibilities. And the last section here is production. And when our artificial intelligence or machine learning model is already running on production, that's not all yet. And in most cases, we still need to continuously monitor the KPIs, metrics, and monitor our data and model for degradation. And even though we're already convinced of the data quality, it might change over time, and data distribution might change as well. And it might be critical for our model, because our model cannot catch new dependencies which were not presented in data previously. So we must take appropriate actions now. And often it is model retraining, which is not a straightforward process sometimes. But there are different ways to handle it as well, which was successfully used, and thank you for our ML operations team. So it will be also out of topic today. So two sections we will mostly stop on will be processes and skills. And we would like to present you evolutionary AI approach to make our processes better. And before presenting evolutionary approach, let's briefly remember the coherent approach we used to work with and still work in some cases when we have clear requirements and we use it for relatively small projects, and some challenges we might face using it. So coherent approach is a waterfall-like approach where outcomes of each step are inputs for the next step. For instance, outputs or design queries are used for the implementation. And in this approach, you negotiate with your customer only once in the very beginning of the project on the discovery phase. And despite wide usage of this methodology successfully for different areas, there might be some critical issues and challenges for data science. And because from AI perspective, it might be a bit difficult for large projects to identify proper processing, models, algorithms, and sometimes even outcomes of your solution before the first attempt of building some prototypes and some parts of your solution or performing exploratory data analysis. For instance, we had a case when we were asked to do some optimization task and client was pretty sure what he needs. Even he explained detailed formulas with coefficient, and the only thing he needed from us just to implement it. When we suggest doing something a bit different based on our expertise, he rejected and said that he is sure about his business, about his requirements. So we agreed to work with this coherent approach. And in the very end, when all was done and almost released, he asked to redo almost everything because he realized that there were lots of mistakes in his assumptions and he expected different numbers. So it led to extra efforts, when the solution is done and released. But if we were using waterfall approach, evolutionary approach, it wouldn't happen. So what is an evolutionary approach? This is a step-by-step approach as well. However, the steps are a bit different. After each small step, it might be like any step, data investigation, data analysis, some small prototype or implementation of some small part of the tool. Feedback session with client occurs, and on such session, client suggests some adjustments from the business point of view, because domain expertise is critical for data science. And each next step transforms the result of the previous iteration, increasing the business value. So on another case, client might ask for some dashboard with insight, but he didn't know which exactly insights he wants. And if you do it in coherent approach, not confirming if it's useful insights for her business, there might be some issues in the very end after the release. But we worked with evolutionary approach, creating a population of insights, selecting the most useful of them based on his business needs, and doing some adjustments and improvements for his business per request. And that's how evolutionary approach makes your client happy, and the solution in the very end for him is not a surprise, and you spend much less time and effort on the UAT stage, having the solution of actual interest because the user was directly involved in the implementation. And in collaboration with domain experts, you achieve the highest quality and minimal changes are required then. Now, when we define the approach we would like to follow, it is time to define our team composition. And there are a few options to consider. The first one is experimentation-oriented team. Such team requires a data scientist with wide profile, since we might need many competencies for our experiment. And it is a good team for performing research activities, doing exploratory data analysis, or conducting some small POC and finding insights. However, outcomes of this team are mostly some reports with insights or small POC. So if we're building some big solution, or if we're building MVP or we are on post-MVP stages, we should consider different options. So for instance, it might be feature-oriented team. It is a team where for each feature we have dedicated member from all disciplines, especially data science. And feature by feature, we are building our solution. It is a classic widely used approach, which are a good match for agile methodology, and the good thing is that team are aware about the solution. But we have an issue that it might be suboptimal in terms of resources distribution for data science competency as well, since as we discussed, data science is wide technology, and sometimes it is better to dedicate different people for different parts. But it is a good option for relatively small teams who don't have a lot of data scientists for each part. And the last option is service-oriented team. In this case, you have a pool of people for data science competency, and each person is assigned when the task of their main competency appears. In this case, everyone has very clear scope of responsibility and do what they can do best. It is difficult to use such team structure for small teams, since you have to introduce many roles even for a single data science competency, and Dmytro will present you these roles after that. But for bigger team, it might be a perfect option to use team skills of each member up to the maximum.
Okay, Natasha, thanks for the great intro, clear overview of the evolutionary AI framework and team structure. What's the next? If you know the problem, we need to solve this problem, and we need to define the proper steps in our journey for solving this problem. Let's have an overview of our AI lifecycle. Okay, I want to start with a very high-level AI lifecycle. As you see, we have a couple of stages, and starting of our journey we defined as adoption stage with discovery, assessment, and ideation and problem framing. And in the end, we have impact measurements of our journey. To better understand the business problem and solve it, we start with this ideation and problem framing. And after gathering all requirements and preparing our vision of a solution, we can build a suitable model for answer the question or predict something or make business happy with applying AI to the business. A couple of years ago, we spent a little time on the operational stage and moved forward to the business step. But now we should be more careful about the operational stage because we have to focus on ML experiments. We have to make it faster, and we need to make a lot of iteration of model development, and we need to include CI, CD, and CT. CT is continuous training for essential monitoring and to train a model in an intuitive way. And as you see, we care now about end-to-end ML workflows at scale for solving this problem. And we move forward from data science, including MLOps step, to decision ops. And it definitely improve our solutions now. Okay, let's move forward to our latest version of AI lifecycle. And as you can see, we have the same steps as I mentioned before. We start with discover, move to implementation, prototype, and in the end, we have evolve stage for release prototype to final user. And in the end, we make impact measurements. And please keep in mind, this is only one iteration. If we need more, it's not a big problem. We start again this life cycle and again before we solve the main problem for business. Okay, so let's have a brief overview each of step. In the discovery step, we need assessment and ideation to understand how we build a solution. Then we should prepare the scope and roadmap of the project, including solution and feature design for moving forward to the implementation step. In the implementation step, we combine three things together. Firstly, we combine data science part with data engineering and operational part. So let's stop each of them by one by one. The data science part is more about data understanding with exploratory data analysis and data mining and model development. It's more about how to use insights in knowledge in data to build the proper model and define the right model pipeline and inference of the model. The next step, the next part of implementation step, it's data engineering, and it's more about feature pipelines, building feature stores, data connections, data lake or data warehouse preparation. And the third part, it's operational part, how to set up CI/CD infrastructure, how to implement model pipelines and continuous testing, and how integrate to external system. And its step is so important, is so huge. And when we finalize our prototype, we will be ready to release to final user and move forward to evolve step with monitoring, serving, and support our application and solution. Okay, as Natasha mentioned, skills are one of our challenges. And if we know how to define process, how to define AI lifecycle, let's define AI competencies and make AI projects more efficient with AI lifecycle. Let's understand which skills we need for this. As you see, we duplicate AI lifecycle, but we change the things which we do with competencies which we need for each step. For covering the discover step, we need business problem leveraging and clients leadership for understand why business needs AI and data science and how data science can help business for improving and make revenue bigger. We need stakeholder management and insights extractions because power in understanding data in proper way. For implementation prototype stage, for data science part, we need deep learning, machine learning, and statistics to combine these things to organize model pipeline. For data engineering part, we need data processing, data quality, and data storage skills. For operational stage, we need MLOps, we need orchestration and cloud services. And I want to admit three things. It's stakeholder management, software development, and ML engineering. It's skills we need, these skills we need across all three things together for preparing proper prototype. And when we're ready to release to final users, we need software development and operations for support our solution. Okay, how can we better organize our competence map? As you know, we have a fantastic people excellence platform in our company, and mostly a lot of us use this platform for evaluate performance and move forward level by level in our company. And now we are implementing our competence map in people excellence, and we actually finish it with design stage. And now we are testing our requirements for junior, intermediate, senior, and lead levels. And I hope in the nearest future, you will be able to understand better what you need if you defined AI and data science as primary direction for your development. Okay, I don't want to describe all details of our competency map, but let's briefly overview a couple of competencies group. And I want to start with machine learning engineering. This is one of the main parts of our skill sets. And let's start with cloud ML services. We have three levels of experience and skills, and it's the same as usual: qualified, competent, and expert. Let's make briefly overview one by one. For qualified level, you should use Cloud ML platform for building simple model pipeline. It can be Azure, AWS, or GCP, but you should know which services give you possibility to build model pipelines build model pipelines. For the next level competent, you should use Cloud ML platform to implement end-to-end model lifecycle. It's not about data preparation or model deploy or model inference. It should be end-to-end lifecycle. And for expert level, we defined design solution architecture based on Cloud ML platform. You should know pros and cons of each cloud services, how combine to one solution, and what solution gives possibility to solve the problem in efficient way. The second one, I want to mention MLOps, and MLOps, it's the main direction for us. We have separate cluster in our group with more than 15 ML engineers and ML architects, and we develop this cluster, and it's our main priority for this and next year. Okay, what we define for qualified level? You should apply MLOps principles to ML in production. For next level, you should understand MLOps best practices and how to organize, for example, feature store, or how to build CI, CD, and CT continuous training for model pipelines, because you know CI and CD for software development. We operate with model in addition, and model also became a part of this process, and our ML engineers and ML architects should solve this issue to including model as artifact to deployment strategies. And for expert level, we defined the same design solution architecture based on MLOps principles and best practices. Okay. Oh, sorry. Oh, yeah. In connection to ML engineering, business problem leveraging is a fundamental skills for us, because as you saw before, we start with discovery and ideation step. And for business problem leveraging, firstly, you should understand the role of data science in business, in enhancing business efficiently. Why business needs data science, how data science or AI can help business, and what's the power of using data science for solving business problem. For competent level, you should transform business problems in data science problem, because for example, very often business needs to make revenue bigger, or change and improve some processes, some business processes, or enhance some metrics. And it's not a data science problem. In data science, we have classification, regression, optimization problems. We should find some clusters, some similarities. We should predict something or understand some patterns in data. And you should transform business problems to data science problems for understanding how and what you apply from all zoo of data science techniques. And for expert level, you should design data science project roadmap. You should understand each step of AI lifecycle. You should understand what you need for how you apply each step, and what amount of FTEs in team you need, and timeline of each step. For example, we need 2 weeks for data analysis stage. After, we need 2 months with 2 FTEs for model development. And after, we need, for example, 6 months with 2 ML engineers to implement in proper way model pipeline. Okay, and the latest one, this is visualization and insights extraction. Everyone in data science know and use plot. It's a way how to visualize what you think, what you find, and what you will use. And firstly, for qualified level, you should know how visualize data with plots. You should know simple plots, type of plots, what type of plots you should use for visualize categoric or numerical data, or etc. For the next level, we defined the presenting data insights for non-technical users, because we have a lot of different plots, and people doesn't know all these things, and you should use proper plots for visualize data for non-technical users. And for expert level, you should prepare an exploratory data analysis and data quality report. It's more about how understand and organize all insights and all knowledge which you found in data. Okay, we're done with the process. Mostly we describe skills, and so let's define job profiles and responsibilities for them. As Natasha mentioned, it's so hard to have many unicorns who can handle all steps in the AI lifecycle. Definitely, we happy to have a few of them in our team, but for efficient team building, we prefer to define job profiles based on skills and responsibility. And on this heat map, you can see main steps which we defined before. Firstly, I want to describe couple of them: problem framing, architecture, design, scoping, and acceptance. It's more about discover stage, data investigation, model development, and model operationalization. It's about implementation step, and feature release and supported maintenance. It's about evolve step. And we define the next job profiles to handle part of them, some parts of all this cycle. You can find applied scientists who focus on data investigation and support and maintenance, research analyst more focus on discovery stage, data scientist on model development and data investigation, ML engineer on how to implement model pipeline and model operationalization step, and ML architect, it's more about architecture design and oversee of ML engineer works. And if you project all the things to one line with steps, you can see we cover any step, but it's better to define job profiles to handle part of our work better. So let's describe one by one profile. Who is applied scientist? Applied scientist has strong experience in software development, deploying application, apply all these things for building pipelines, data model, and dashboarding. Also has basic knowledge of data mining and data science, and primarily focus on tabular data. The next, who is research analyst? Research analyst has strong experience in data analysis, statistics, and data mining, and apply all these things for finding insights and data and provide exploratory data analysis. Because we need to understand data in proper way for building efficient model for solving business problem. And data scientist has strong experience in data science and state-of-the-art techniques in AI. Data scientists focus on tabular data, time series, digital signal processing, text data, images, video, any kind of data. And we define some competency profile, but you will see details in People Excellence platform. As the main focus for data scientists is developing models according to architecture and its size, because it's so important to understand environment and architecture requirements, functional and non-functional requirements, to prepare the right model pipeline, because it can be cloud, it can be on-premise, or it can be some environment with GPU or without GPU, or you should satisfy some non-functional requirements. And based on all these things, data scientists will define the proper model development cycle. Okay. ML architect accommodates strong experience in machine learning, data engineering, DevOps to design AI system end to end. And after ML architect will oversee of the ML engineering work. ML engineer is responsible for building and for building AI solution by leveraging best practices in software engineering, ML, DevOps. In addition, they are closely working with data science and IT teams to build infrastructures, process, product, integrate different pipelines into existing business environments. And I want to continue with RACI matrix. We have done with challenges regarding skills, defined job profiles. And Natasha, could you describe the main idea of the RACI matrix and how we defined it for our profiles?
Sure, thank you, Dima, for a great introduction. So let's discuss RACI matrix, which is kind of a structured summary of our different roles and responsibilities. Okay, of course, for every step of the solution, there are multiple people involved, so we have different roles, and you can see the list of them. All right, in any stage, we have one or several people responsible because someone have to do a job. And in this case, responsible means that this person creates acceptance criteria, creates technical description of the tasks, and potentially doing or monitoring the job. And always we have only one person accountable. It is the person who is an owner of the outcomes of this stage, and this person confirms that deliverables and confirms that the tasks are done as expected. And there are also two optional roles that might take place on any stage. It is consulted and inform. And the person who is being consulted provides some valuable inputs to help responsible person complete the task. But they are not creating any deliverables and not blocking an acceptance step. And informed people just need to be kept in picture. They have to be updated about progress, about decision made, to have such information because they might need it later, for instance, on first stages. But they do not contribute to the task on this stage. So this is the RACI matrix, and on the left you can see the steps, and these steps are for discovery. So we usually start from ideation and design thinking, as Dmytro mentioned, and from AI side, we have here our research analyst who worked closely with business and closely with business analysts to identify client needs and to identify what we can suggest as a solution from AI perspective. And then going to solution and feature design, we still have our research analyst here, who might consult our data scientist. And also on solution and feature design step, we have our AI and ML architect to overview the technical picture. And then we have our technical assessment architecture, which should be conducted by our AI and ML architect. Then take place scoping and roadmap. And on this stage, everyone, almost everyone from AI team have to be consulted so that they can confirm that scoping is okay from their side and that roadmap and estimates are correct. Okay, then we have implementation phase, and there are much more people involved from our side, starting from applied scientists who does an engineering job, as Dmytro mentioned. So starting from a data transformation, which he does in collaboration with data engineers. And then we have exploratory data analysis, which is done by research analysts as a continuation of discovery phase to find more data insights and then to perform data mining. For feature pipelines and feature store is such place where our data science team store all the structured and already pre-processed data to be used for modeling. So it is done as well. The pipelines are done as well for applied cities, of course, using the results of data mining and EDA from research analysts. But the model development is done by the data scientist, and of course, data scientists should be consulted for previous stages by applied scientists and research analysts to confirm that everything is okay from his side. And then model pipelines and continuous testing, of course, as Dmytro mentioned, is done by MLOps. And then from our side, if integration to external system is needed, this engineering part is also done by applied scientists. Okay, and the last stage is release stage. Here we have as responsible only an applied scientist who conduct operation and support in case when any adjustments or fixes are needed. And on release and production and maintenance, we can consult on the ML engineer or AI and ML architect. And on monitor and impact measurement, the consulted people are research analysts and data scientists if needed. So you've already seen this plot, but it is a summary again. Just maybe it's easier to understand after this RACI matrix. So as we discussed before, from the very beginning, we have research analyst for problem framing, and then ML architect helps with technical design and architectural design. And for scoping and acceptance, we also have research analyst and ML architect. And then on first stages for implementation, we have applied scientist for data integration and data scientist for modeling, and he consults for other stages. And we have ML engineer for model development and operations, and ML architect helps with operations as well. And in the very end, in the release stage, we have applied scientist for feature release and impact measurement and support. Okay, and of course, for each of these steps, we have some deliverables. So we have set up for each step goal, inputs, and deliverables. And we are not going to stop on it very detailed today. However, after the speech, we will share this presentation with you. So who is interested in might check and then ask any questions. Okay, thank you so much. That's it from our side. So if you have any question, we will be happy to answer.